we now know that a 90-degree rotation in Fischer projections is not allowed because it results in change of the absolute configuration. What about 180-degree rotation? Let's see. If we begin with something like this, where the lowest priority group, for example, at the top, and then we have 1, 2, and 3. So this is a Fischer projection. And of course, remember, these numbers reflect priority. So 4 is the lowest priority group, and it is at the top. And if you check rotation here, you will see it's actually clockwise. Therefore, it is R. So this is an R absolute configuration. So this is the absolute configuration. This is how it should be determined. Okay, the lowest priority group is at the top, and then we check rotation. Let's do 180-degree rotation on this, and then we will see the effect of this rotation on the absolute configuration. Remember, if the absolute configuration remains the same, then the rotation is allowed. If it doesn't, it should not be allowed. And we already acknowledge now that a 90-degree rotation is not allowed, again, because it results in change of absolute configuration. So if we do 180 degrees, so 180-degree rotation, okay, this is what we get. Of course, 4 replaces 2, so we get 4 here. 2 replaces 4, we get 2 at the top. 1 replaces 3, 3 replaces 1, so we get 1 here and 3 here. So 4 and 2 swap positions, 1 and 3 swap positions, so this is a 180-degree rotation. Let's try to determine the absolute configuration on this new Fischer projection. So what do we need to do? We need to place always, as usual, the lowest priority group at the top. Is it at the top? No, it isn't. So we have to hold one group fixed or steady, and then we rotate clockwise or counterclockwise. If we hold, for example, 3, we hold this steady. We hold group number 3 steady, then we rotate counterclockwise. What we arrive at is another Fischer projection. Of course, remember, 3 is held steady. Group number 3 is held steady. So now we rotate this way or counterclockwise. We get therefore number 4 here. Of course, 4 replaces 2, 2 replaces 1, and 1 replaces 4. So we rotate like that. So 4 becomes at the top, 2 becomes here, and 1 becomes here. So we get that new Fischer projection which has the lowest priority group at the top. Now, if we check this, so this is the lowest priority group. It's drawn at the top. It is at the top. So now what we need to do is only to check rotation. And 1, 2, 3, and clearly this is R. So we have R here, and we began with R, and of course the absolute configuration remains intact. It's not changed as a result of this 180-degree rotation. So in summary, a 180-degree rotation is actually allowed in Fischer projections because it does not result in change of absolute configuration. If you have R, if the configuration is R, the new configuration in the structure after the 180-degree rotation is still R. If we begin with S, we end up with S. So therefore, a 180-degree rotation is actually allowed in Fischer projections.